Okay, let's talk about lesson 6 in chapter 4, misleading graphs and statistics. There's many things that happen when you see a graph or a statistic on the internet or on TV or hear it from somebody, a statistic. You are trying to be persuaded to purchase something, to change your point of view, or do something like that, is often what the case is. Advertisers, especially, may accidentally or more likely intentionally present the information in a misleading way. So we need to be able to identify or at least be aware that any graph or any statistic that is used that we hear, we may need to analyze it to see if it's misleading. For example, art is a common tool used to make graph more interesting, but it can distort the relationship of the data. What do we mean by that? Well, let's first take a look at identifying some misleading graphics. This is a graph of the ticket prices for baseball in the year 2000, 2010, and 2020. Now, this graph, these three baseballs, is maybe a little bit hand-drawn, but still it is art. And if you can see, what we're trying to reach here is what is the height. So in 2000 we had a $20 ticket. In 2010 we had a $40 ticket, and in 2020 we had an $80 ticket. Now, by using the baseball drawings, right here, and right here, we made the chart a little bit more interesting, and if you were a really good artist, maybe a lot more interesting. But instead, what we've also done is we've kind of distorted the graph. Because let's take a look at the size of that guy. The size of that baseball is basically, I suppose we could get 1, 2, 3, maybe 4, and there's probably enough room for a fifth ball in there. So if you look at the area of these baseballs, this baseball looks to be about 5x of this baseball, which is 1x. And if you carry that forward, you can get about another 5 of the medium-sized balls inside of here, and this size is about 25x. But what we're really looking at is a $40 increase to $80. So we're really looking at plus 40. So we're looking at a 40, maybe 100% increase, because we went from 40 to 80. But instead, by drawing this graph, we kind of trick the user of the graph, the person who's looking at it, and we trick their eye into thinking that maybe this is a lot bigger than this first one down here. In reality, we should have drawn a simple bar graph, and you can see that the height of these three and the whole thing more corresponds with what you're really trying to tell a story. In that story is that this height here is plus 40, which is your 100% growth. And the bars themselves, this bar and this bar, have basically proportionally the same area also. You could just stack 2 of these medium-sized bars on top of each other and you would get the full 2020 bar. So there's no trick being played on your eye with area or anything. That's how that should have been drawn. Let's look at another example. The second example is, let's talk about the lifetime of a running shoe. Okay, the lifetime of the running shoe in miles. Okay, we've got brand 1, 2, and 3, and the number of miles at the bottom. We can see that brand 1 looks like it made it about 450. Brand 2 looks like it made it about 475, and brand 3 made it to about 550. Okay, and that looks like pretty good lead there for brand 2 over brand 3 and over brand 1. But the misleading part of this process, or this chart, is that they started at 400. Instead of starting at 400, they should show all their data and the whole relationship of the whole data, and that means start at 0. They should have started their bottom part of their chart at 0. So if they do here, you can see that we still have the bottom line coming in at 450. We still have the top line coming in at about 475, and we have the middle line, brand 2, coming in at about 550. But now the actual difference between these guys is more in relationship with the overall length of the chart. And you can see that since they started on 400 on the first one, what I'm highlighting here is the part of the chart that you don't see. So if we scroll back and look at the chart which started at 400, you can see that this difference looks a lot bigger because we're just not showing the first 400 miles on our chart. If you come over here and in the yellow spot, you can see the first 400 miles. You can see that the differences seem a little bit less because the relationship between the bars is accurate. So two misleading ways. One was with the fancy piece of art, which maybe distorts how your eye adjusts and sees the art. The second one is obscuring the data by not starting it at the starting point of 0. Okay, and let's look at a third way. Registered vehicles. Okay, each one of these circles represents 9 million cars. Each one of these boxes represents 9 million pickups. Each one of these boxes with the X in them represents 9 million semis. So if I were to ask you to compare those three, it's a little bit misleading because the symbols that represent cars here is the smallest symbol. It's the shortest symbol. So if we really wanted to look at this, that's 4, 5, 6, 7, 8, 9, 10, 11, 12. There's really 12x times 9 million, or 108 million cars on the road. And if we look at the 1, 2, 3, 4, 5 here, there's really 5 times 9 million, or 45 million pickups on the road. And finally, if we look at the 1, 2 semis, there's really 2 times 9, or 18 million semis on the road. So if you really look at it, the car, 108, is really more than twice the number of pickups. But if you look at the overall line that is represented, this line goes just that far, whereas the line of pickups goes almost as far as the cars. And we know that it should be less than half. So we're misleading the viewer of this chart by making it look like the pickups are more in relationship to the cars than they really are. And once again, we do the same thing with the relationship of semis to pickups or semis to cars, because the icon that we use to draw them is too big, too wide compared to the icon we use to draw the cars. So if you don't watch what you're doing, you can accidentally skew a document or a chart and make it look misleading. How about just misleading statistics? Let's not look at how it's displayed, but what somebody says. Let's take a look at some examples. We have a small business, has 5 employees. Here's the salary list of those employees. Okay, and the owner runs an ad, help wanted, average salary is $34,600. Well, if I was reading that ad, I would say that he's going to give me a job somewhere around $34,000 because when I apply for the job, I expect to get it, and that's the kind of job I would want. However, he's not going to pay that because you can look at his employees, not including himself as the owner. They really only make between 18 and 23,000. So real life this is going to be more like a 18K to 23K job. And so it's misleading for him to say that as his average salary. Once again, if you remember the term we used a couple lessons ago, this $90,000 is considered an outlier, an odd number that doesn't fit with the other numbers. In this case, it's obvious because he's the owner. He's taking the lion's share of the money out of the business. Let's talk about a second example here. A market researcher randomly selects 8 people to focus test 3 brands, A, B, and C. Of these, 4 chose brand A, 2 chose brand B, and 2 chose brand C. Then the ad for brand A says, hey, preferred 2-to-1 over leading brands. How is this misleading? Well, first of all, it's 100% true. Brand A had 4 people choose brand A, and only 2 chose brand B or C. So brand A really is a 2-to-1 favorite over the leading brands. However, if you look at this more closely, you see that they only interviewed 8 people. So in reality, 2-to-1 here is just 2 people. If you go from 4 to -2, there's only 2 people difference between brand A and brand B or brand C. And so this is misleading because the amount of people that were talked to is just too small. 8 people is not enough, and a difference of 2 people on a survey is insignificant, especially when you can't count on that happening over a large scale amount of people. How about the next one? Total revenue for store A for 3 months from June to September was $72,000. Total revenue from store B for 3 months from October to January was $108,000. At first glance, you'd say to yourself, well, store A didn't do as well as store B, only $72,000 to $108,000. But why is this misleading? Well, store A was done, the data comes from June through September, and store B comes from October through January. If you don't measure at the same time, you may have differences in buying patterns that really affect the data. And in this example, what happens in this time frame right here? Christmas. So there's a lot of buying processing that's going on in store B's measurement of their revenue for those 3 months. So it's misleading to compare these 2 numbers just because of the differences in the time factor. How about another 3 quick ones here? Sam scored 42 goals and Jim only scored 2. Sounds like Jim's not a very good player. But in reality, we don't know enough about this. Maybe Jim was the goalie. Maybe Jim only got out of the goalie for a little bit and had 2 goals on the year, which is pretty good. Maybe Jim was hurt. Maybe Jim only played 1 game. And Sam played them all. We don't know. This is why this is a misleading stat. You're not sure about all the details. You assume when you read something like this that everything's been measured out and it's basically equal, but there's real reasons behind the data that may make Jim scoring only 2 quite a better feat than Sam scoring 42. The next one is 4 out of 5 dentists prefer UltraClean. Well, first of all, on this, they prefer ultra clean to what? What do they prefer it to? We don't even know. Maybe they were preferring ultra clean toothpaste to the worst toothpaste on the market, or were they comparing it to the best-selling toothpaste on the market? We don't know. So there's just not enough data here. Also, in real life, a lot of times surveys like this allow dentists to pick 2 or 3 brands, and thus ultra clean could be one of the 2 or 3 and actually end up winning, being a preferred by 4 or 5, but their competition could also be 4 out of 5 prefer the competition. We don't know enough about how they did their survey. And finally, we got shop at Save-A-Lot, can save you up to $100 per month. And the key words here to look at is, how is this misleading? Well, it can save you up to $100. It doesn't guarantee that you're going to save $100, but it makes it sound like it. You're going to save $100. Matter of fact, it doesn't even say that you're going to save. You could save. It doesn't say you will save. It just says you can save. So maybe you're going to spend more. And maybe your savings will only be $1. There's just no guarantee in the way this is worded of what you're going to have for savings. All right, and so basically at the end of this lesson, recap it real quick. Go to the top here. There's misleading graphs that you can find, okay? And we notice that area of an icon of a picture allows us to dispute or make maybe a bad picture, where if we keep the area consistent, it makes a better picture. We also saw where if you cut off the beginning of your data set, you can make the differences look skewed and bigger and different than what they really are. Whereas if you put all the data on your screen, the differences are proportionally correct, and people can make decisions on that. Here's another version where the icon used to represent each of the 3 different kinds of vehicles here are not the same size, and so the overall picture gets skewed and isn't as good as it could be. And misleading stats, you just got to look at them and look for outliers. They may have done stuff. Look for ways that the words that are said out loud in the ad are maybe just ways to make the data look good without lying. And then you just look for reasons or data that's hidden behind the data you see to ask, well, do I know everything? Is this a valid statement or not?